So we're going to define a new term, and our new term is the term antiderivative. So we've talked about finding derivatives of functions, and now we're actually going to learn kind of how we can go backwards. So we say a function f is an antiderivative of little f. So we say big F is an antiderivative of little f on an interval I. And here's the important part. If the derivative of big F is equal to little f for all x in that interval. Okay, so let's give some examples. So if we have the function f of x equals x squared, then big F needs to be something so that if we take the derivative, so we take the derivative of this and get x squared. And we'll talk about how to do that, but this we could do 1/3 x cubed. And if we took the derivative, right, f prime of x, we would use the power rule. We'd say 3 times 1/3, which is 1. We'd subtract 1 from the power, so we'd get 1x squared, or x squared. Okay? So let's give it another example. So if we have f of x equals cosine of x, then big F of x is going to be the function that if we take the derivative of it, we get cosine, and that's sine of x. So we'd have sine of x. And we know that the derivative of that is equal to cosine of x. Okay, and let's do one more example. So let's say f of x is equal to e to the x. Well, then we'd want a function that if we take the derivative, we get e to the x. And we know e to the x is its own derivative, so the antiderivative would also be e to the x. Okay, now here's something really, really interesting. So this theorem tells us that if big F is an antiderivative of little f on an interval, then the most general antiderivative is big F of x plus c, where c is an arbitrary constant. And here's why we have to have a theorem like this. So, just a minute ago, we said we had little f of x. If we said it was x squared, then we saw big F of x, one option was 1/3 x cubed, right? Well, what if we had 1/3 x cubed plus 7, right? If we take the derivative of that, we would take 3 times 1/3, so 1x squared, plus the derivative of 7, which is 0. So that's just x squared. So that's another antiderivative, right? And this 7, there's nothing special about the number 7. That could be any number. We could put negative numbers in there, really big numbers. It wouldn't matter. The derivative of a constant is 0. So what we're saying here is if we found kind of this most general antiderivative of x squared, 1/3 x cubed, then the most general antiderivative, which is what we'll want to find most times, we'll write it as f of x equals 1/3 x cubed, and then we'll put a plus c, meaning any constant you want to put that in there, the derivative of it would give you x squared. So when you're asked for the most general antiderivative, you'll find this piece, and then you'll say plus c, meaning any constant you put there, it would be that derivative.